History of Artificial Intelligence. Introduction. Define artificial intelligence and its main goals. Give an overview of the history and evolution of artificial intelligence from ancient myths to modern applications. Body. Divide the history of artificial intelligence into 4 main periods. The precursors. Discuss the early attempts to understand and imitate human intelligence by philosophers, mathematicians, and engineers. Mention some examples of mythical, fictional, and speculative artificial beings and machines. The birth of artificial intelligence. Discuss the emergence of the field of artificial intelligence as a scientific discipline in the mid-20th century. Mention some of the pioneers, milestones, and challenges of artificial intelligence research. Explain the concept of the Turing test and its significance. The AI winters and booms. Discuss the fluctuations of interest, funding, and progress in artificial intelligence research over the decades. Explain the causes and consequences of the 2 AI winters and the 2 AI booms. Mention some of the breakthroughs and setbacks of artificial intelligence in various domains. The current state and future prospects of artificial intelligence. Discuss the recent advances and applications of artificial intelligence in various fields and industries. Mention some of the benefits and risks of artificial intelligence for society and humanity. Explain some of the current challenges and open problems of artificial intelligence research. Summarize the main points and findings of the video. Emphasize the importance and impact of artificial intelligence on our lives and our world. Provide some suggestions or questions for further exploration or discussion. Hello and welcome to this video on the history and evolution of artificial intelligence. In this video, we will explore how artificial intelligence, or AI for short, has developed from ancient myths to modern applications. We will also discuss some of the benefits, risks, and challenges of AI for our society and our future. But first, what is artificial intelligence? Artificial intelligence is a branch of computer science that aims to create machines or systems that can perform tasks that normally require human intelligence, such as reasoning, learning, decision-making, problem-solving, perception, language understanding, and creativity. Artificial intelligence is also a multidisciplinary field that draws upon knowledge and methods from mathematics, logic, psychology, neuroscience, engineering, philosophy, and many other domains. The history and evolution of artificial intelligence can be divided into 4 main periods. The precursors, the birth of artificial intelligence, the AI winters and booms, and the current state and future prospects of artificial intelligence. The precursors. The idea of creating artificial beings or machines that can think or act like humans has been around for a long time. In ancient myths and legends, we can find stories of mechanical men, animated statues, talking animals, and other fantastical creatures that were endowed with intelligence or consciousness by gods or master craftsmen. For example, in Greek mythology, there was Talos, a giant bronze robot that guarded the island of Crete. In Jewish folklore, there was Golem, a clay figure that was brought to life by a rabbi. In Chinese literature, there was Monkey King, a magical monkey that could transform into different shapes. And in Indian epic Mahabharata there was Mayudanava who created an illusory palace with his architectural skills. In addition to these mythical and fictional examples, there were also some attempts to understand and imitate human intelligence by philosophers, mathematicians, and engineers throughout history. For instance, in ancient Greece, Plato proposed that human thinking was based on manipulating abstract symbols according to logical rules. Aristotle developed a system of syllogisms for deductive reasoning. Euclid formalized the principles of geometry. Archimedes invented various machines for practical purposes. And Hero of Alexandria designed automata such as a self-moving cart and a steam-powered engine. In medieval Europe, Thomas Aquinas reconciled Aristotelian logic with Christian theology. Ramon Llull devised a method for combining concepts into new combinations. Leonardo da Vinci sketched plans for humanoid robots and flying machines. Blaise Pascal built a mechanical calculator. Gottfried Leibniz envisioned a universal language and a calculus ratiocinator for reasoning. René Descartes argued that animals were automata without souls. Baruch Spinoza proposed that everything was governed by natural laws. John Locke suggested that human mind was a blank slate at birth. David Hume challenged the validity of causal inference. Immanuel Kant synthesized rationalism. Artificial intelligence pioneers. The birth of artificial intelligence. The field of artificial intelligence as a scientific discipline emerged in the mid-20th century. When a handful of scientists and engineers began to explore the possibility of building machines or systems that could perform tasks that normally require human intelligence. Some of the pioneers of artificial intelligence research include Alan Turing, who proposed a test to measure a machine's ability to exhibit intelligent behavior equivalent to human intelligence, known as the Turing test. He also designed the automatic computing engine, one of the first electronic computers. John McCarthy, who coined the term artificial intelligence and organized the first conference on AI at Dartmouth College in 1956. He also invented the programming language Lisp, which became widely used for AI applications. Marvin Minsky, who founded the Artificial Intelligence Laboratory at MIT and made contributions to various aspects of AI, such as neural networks, common sense reasoning, robotics, and machine vision. Claude Shannon, who applied information theory and Boolean logic to the design and analysis of switching circuits and digital computers. He also built a chess-playing machine and an electromechanical mouse that could learn its way through a maze. Herbert Simon and Alan Newell, who developed the logic theorist, one of the first AI programs that could prove mathematical theorems. They also proposed the physical symbol system hypothesis, which states that any system that can manipulate symbols can exhibit general intelligence. These and other researchers made significant progress and achievements in artificial intelligence research in the 1950s and 1960s. They developed various techniques and applications for AI, such as search algorithms, game-playing programs, natural language processing systems, knowledge representation schemes, expert systems, neural networks, genetic algorithms, and more. They also face some challenges and limitations, such as the scalability and complexity of AI problems, the brittleness and incompleteness of knowledge bases, the difficulty of capturing common sense and human intuition, and the ethical and social implications of AI. The AI winters and booms. The history of artificial intelligence research has been marked by cycles of enthusiasm and disappointment, funding and withdrawal, breakthroughs and setbacks. These cycles are often referred to as AI winters and booms. The first AI winter occurred in the mid-1970s, when funding and interest in AI research declined due to several factors, such as the criticism from James Lighthill's report to the British Parliament, which argued that AI had failed to deliver on its promises and was unlikely to do so in the foreseeable future. The difficulty of scaling up AI systems to handle real-world problems that require large amounts of data, computation, and domain knowledge. The competition from other fields of computer science, such as database systems, software engineering, and computer graphics. The first AI boom occurred in the early 1980s, when funding and interest in AI research increased due to several factors. The success of expert systems, which were programs that could provide advice or solutions in specific domains based on a set of rules or facts. Expert systems were widely adopted by various industries and organizations for tasks such as medical diagnosis, financial planning, configuration design, and more. The emergence of new paradigms and methods for AI research. Artificial intelligence application, such as neural networks, genetic algorithms, fuzzy logic, and expert systems. These methods enabled AI to tackle more complex and diverse problems, such as speech recognition, natural language understanding, computer vision, robotics, and more. The influence and investment of Japan's fifth-generation computer systems project, which aimed to create a new generation of computers that could perform high-level reasoning and parallel processing. This project stimulated the interest and competition of other countries and companies in AI research and development. The commercialization and popularization of AI products and services, such as personal assistants, video games, smart toys, and more. These products and services demonstrated the potential and value of AI for consumers and businesses. The second AI winter occurred in the late 1980s and early 1990s, when funding and interest in AI research declined again due to several factors, such as the failure of expert systems to meet the high expectations and demands of users and customers. Expert systems were costly to maintain, difficult to update, limited in scope, and prone to errors. The collapse of Japan's fifth-generation computer systems project, which did not achieve its ambitious goals and was overtaken by other technologies. This project also faced criticism from other AI researchers for its narrow focus on logic programming and symbolic reasoning. The rise of other fields of computer science, such as data mining, information retrieval, and the World Wide Web. These fields offered more practical and profitable applications of computing than AI. The second AI boom occurred in the late 1990s and early 2000s, when funding and interest in AI research increased again due to several factors, such as the resurgence of neural networks and the emergence of deep learning. Neural networks are computational models that mimic the structure and function of biological neurons. Deep learning is a branch of machine learning that uses multiple layers of neural networks to learn from large amounts of data. These methods enabled AI to achieve remarkable results in various tasks, such as image recognition, natural language processing, speech synthesis, machine translation, and more. The availability and accessibility of big data, powerful computing hardware, and open-source software. These resources facilitated the development and deployment of AI systems that could process massive amounts of information efficiently and effectively. The innovation and integration of AI technologies in various industries and domains. AI technologies were applied to enhance or automate various processes and services, such as search engines, social media platforms, e-commerce platforms, recommendation systems, self-driving cars, smart homes. Artificial intelligence challenges. These technologies demonstrated the impact and value of AI for society and humanity. The current state and future prospects of artificial intelligence. The current state of artificial intelligence is characterized by rapid and continuous progress and innovation in various fields and domains. Artificial intelligence is becoming more ubiquitous, accessible, and powerful, thanks to the advances in data, computing, algorithms, and applications. Some of the recent achievements and trends of artificial intelligence include the development and deployment of large-scale language models, such as GPT-3, which can generate coherent and diverse texts on various topics and tasks based on a few words or sentences of input. These models can potentially enable new forms of communication, education, entertainment, and more. The creation and improvement of generative adversarial networks, GANs, which are neural networks that can create realistic images, videos, sounds, or texts from scratch or based on some input. These networks can potentially enable new forms of art, design, entertainment, and more. The emergence and expansion of artificial intelligence ethics and governance, which are the principles and practices that aim to ensure that artificial intelligence is developed and used in a responsible, fair, transparent, accountable, and beneficial manner. These principles and practices involve various stakeholders, such as researchers, developers, users, regulators, policymakers, and civil society. The future prospects of artificial intelligence are both exciting and uncertain. Artificial intelligence has the potential to transform various aspects of our lives and our world in positive ways. For example, artificial intelligence can help address some of the grand challenges that humanity faces, such as climate change, poverty, healthcare, education, and more. Artificial intelligence can help monitor, analyze, predict, mitigate, or solve these problems by providing insights, solutions, or actions. Artificial intelligence can help enhance human capabilities and well-being. Artificial intelligence can help augment human intelligence, creativity, productivity, or happiness by providing assistance, guidance, feedback. Artificial intelligence risks or entertainment. Artificial intelligence can help complement human strengths and compensate for human weaknesses by providing assistance, guidance, feedback, or enhancement. However, artificial intelligence also poses some potential risks and challenges that need to be addressed and mitigated. For example, artificial intelligence can cause job displacement and unemployment. Artificial intelligence can replace human workers in various tasks and occupations, especially those that are routine, repetitive, or low-skilled. This can lead to job losses, income inequality, and social unrest. Artificial intelligence can threaten privacy and security. Artificial intelligence can collect and analyze large amounts of personal data, which can be used for malicious purposes, such as identity theft, fraud, surveillance, or manipulation. Artificial intelligence can also be hacked or weaponized by adversaries, which can compromise the safety and integrity of systems and users. Artificial intelligence can raise ethical and moral dilemmas. Artificial intelligence can challenge human values and norms, such as dignity, autonomy, justice, and responsibility. Artificial intelligence can also create conflicts of interest, accountability, and liability among various stakeholders, such as developers, users, regulators, and society. Artificial intelligence is a powerful and transformative technology that has the potential to bring significant benefits and opportunities for humanity. However, artificial intelligence also entails some serious risks and challenges that need to be carefully considered and addressed to ensure that artificial intelligence is developed and used in a responsible, fair, transparent, accountable, and beneficial manner. We need to adopt a multidisciplinary and collaborative approach that involves various actors and perspectives. We also need to foster a culture of learning and innovation that encourages curiosity, creativity, and critical thinking about artificial intelligence and its implications for our lives and our world. Welcome to a captivating journey through time, exploring the fascinating history and evolution of artificial intelligence. From its humble beginnings to the cutting-edge advancements of today, AI has revolutionized various industries and transformed the way we live, work, and interact. Join us as we delve into the origins, breakthroughs, and future possibilities of this groundbreaking technology. Our story begins in the mid-20th century, a time when the concept of artificial intelligence first emerged. In 1956, a group of visionary researchers, including John McCarthy, Marvin Minsky, and Alan Newell, organized the Dartmouth Conference, marking the birth of AI as a formal field of study. Images of John McCarthy, Marvin Minsky, and Alan Newell. Vintage computer systems and punch cards. The early pioneers believed that machines could be programmed to exhibit human-like intelligence. However, progress was slow due to limited computing power and the absence of comprehensive algorithms. In the 1960s and 70s, significant breakthroughs laid the foundations for AI. The introduction of symbolic reasoning and logic-based systems brought forth the development of expert systems, which aimed to mimic human expertise in specific domains. Diagrams illustrating symbolic reasoning and logic-based systems. Examples of early expert systems. One notable example was the 𝗰cie system, developed at Stanford University, which demonstrated remarkable diagnostic capabilities in the field of medicine. However, these early AI systems were limited in their ability to handle uncertainty and lacked the capacity for learning. The 1980s witnessed a significant shift in AI research, with the emergence of machine learning techniques. Instead of relying solely on explicit programming, machine learning algorithms enabled computers to learn from data and improve their performance over time. Illustrations of neural networks and machine learning algorithms. Examples of machine learning applications, such as handwriting recognition. One milestone achievement during this period was the development of backpropagation, a technique for training artificial neural networks. This breakthrough paved the way for advancements in image and speech recognition, leading to the creation of practical applications like optical character recognition, OCR. Despite the promising advancements, the late 1980s and 90s witnessed a decline in AI research. Funding dwindled, and public interest waned, leading to what became known as the AI winter. Newspaper headlines highlighting the decline of AI. Researchers packing up their labs. However, behind the scenes, AI continued to evolve. Researchers explored alternative approaches, such as probabilistic reasoning and evolutionary algorithms. This period of introspection and refinement eventually set the stage for the AI renaissance in the 21st century. With the turn of the millennium, AI experienced a resurgence driven by advancements in computational power, the availability of vast amounts of data, and breakthroughs in algorithmic techniques. Graphs showing the exponential growth of computational power. Visualizations of big data and data processing. Machine learning techniques, particularly deep learning, demonstrated unprecedented capabilities in image and speech recognition, natural language processing, and more. These advancements powered the widespread adoption of AI in various industries, including healthcare, finance, and transportation. In the modern era, AI has become an integral part of our daily lives, our homes, workplaces, and even our smartphones. Virtual assistants, such as Siri and Alexa, provide voice-activated convenience, while recommendation systems personalize our online experiences. Clips of people interacting with virtual assistants and smart devices. Examples of personalized recommendations on social media and streaming platforms. AI has also made significant strides in robotics, with the development of autonomous vehicles, industrial automation, and humanoid robots. The integration of AI and robotics has the potential to revolutionize industries, enhance productivity, and improve our quality of life. As AI continues to evolve, so do the ethical considerations surrounding its deployment. Issues like bias in algorithms, privacy concerns, and the impact on the workforce need to be carefully addressed to ensure a responsible and inclusive development of AI technologies. Images depicting diverse individuals to represent inclusivity. Headlines and news articles on AI ethics and bias. Researchers, policymakers, and industry leaders are actively working towards developing ethical frameworks, regulations, and guidelines to ensure AI is used for the benefit of humanity while minimizing unintended consequences. Looking ahead, the future of AI holds immense potential. As computing power continues to advance and new breakthroughs emerge, AI is expected to tackle even more complex tasks, such as drug discovery, climate modeling, and personalized medicine. Concepts of futuristic AI technologies, like advanced robotics and augmented reality, visualizations of AI applications in various industries. Moreover, the development of explainable AI aims to provide transparency and interpretability, enabling humans to understand and trust AI systems. Collaborations between AI and human intelligence hold the key to solving some of the most pressing challenges of our time. From its modest beginnings to the dynamic landscape of today, the history and evolution of artificial intelligence have been a remarkable journey. As AI continues to shape our world, it is crucial to embrace its potential while upholding ethical principles and ensuring its responsible development for the betterment of humanity. Thank you for joining us on this enlightening exploration of the history and evolution of artificial intelligence. As we stand at the precipice of a new technological era, let us embark on this path with curiosity, foresight, and a commitment to harnessing the power of AI for the benefit of all. Thank you for watching this video on the history and evolution of artificial intelligence. We hope you enjoyed it and learned something new. If you have any questions or comments, please view this video about robotics and artificial intelligence. In this video, we will explore what robotics and artificial intelligence are, how they are related, what are some of the recent advancements and challenges in these fields, and what are some of the potential applications and implications of these technologies for the future. What are robotics and artificial intelligence? Robotics involves the creation of robots to perform tasks without further intervention, while AI is how systems emulate the human mind to make decisions and learn. Robots are machines that can sense, actuate, and communicate with their environment. They can be classified into different types based on their shape, mobility, autonomy, and functionality. For example, some common types of robots are industrial robots. These are robots that perform repetitive or dangerous tasks in factories, such as welding, painting, assembling, etc. Service robots. These are robots that provide services to humans or other machines, such as cleaning, delivery, entertainment, etc. Social robots. These are robots that interact with humans in a social or emotional way, such as companionship, education, therapy, etc. Military robots. These are robots that are used for defense or combat purposes, such as reconnaissance, surveillance, attack, etc. Artificial intelligence is the science and engineering of making machines that can perform tasks that require human intelligence. AI can be classified into different types based on their level of complexity and generality. For example, some common types of AI are narrow AI. This is AI that can perform specific tasks well within a limited domain or context, such as playing chess, recognizing faces, translating languages, etc. General AI. This is AI that can perform any intellectual task that a human can do across multiple domains or contexts, such as reasoning, planning, learning, etc. This type of AI does not exist yet but is a long-term goal of AI research. Super AI. This is AI that can surpass human intelligence in all aspects and domains. This type of AI is also hypothetical and may have profound implications for humanity. How are robotics and artificial intelligence related? Robotics and artificial intelligence are closely related fields that often complement each other. Robotics provides the physical embodiment and interaction for AI systems, while AI provides the cognitive capabilities and intelligence for robotic systems. By integrating AI with robotics, we can create robots that can perceive, reason, and act autonomously in complex environments. For example, perception. This is how robots use sensors, such as cameras, microphones, lasers, etc., to acquire information about their surroundings and themselves. AI techniques such as computer vision and speech recognition enable robots to process and interpret this information. Reasoning. This is how robots use logic and knowledge to make decisions and solve problems. AI techniques such as machine learning and deep learning enable robots to learn from their experiences and improve their performance over time. Action. This is how robots use actuators, such as motors, grippers, wheels, etc., to execute tasks and manipulate objects. AI techniques such as planning and control enable robots to generate and execute optimal actions based on their goals and constraints. What are some of the recent advancements and challenges in robotics and artificial intelligence? Robotics and artificial intelligence have made significant progress in recent years thanks to the advances in hardware, such as sensors, processors, memory, software, such as algorithms, frameworks, data, such as availability, quality, and collaboration, such as interdisciplinary. Open source. Some of the recent examples of achievements in these fields are 𝗧𝗯𝗹𝗲. This is an AI system developed by DeepMind that can master any two-player board game, such as chess, Go, entirely through self-play. 𝗧𝗪. This is a nuclear fusion reactor in South Korea that uses an AI-powered robot to maintain its plasma temperature at over 100 million degrees Celsius for 30 seconds. 𝗧𝗯𝗹𝗲. This is a four-legged robot developed by Boston Dynamics that can navigate rough terrain, climb stairs, and perform various tasks such as inspection, delivery, and dancing. 𝗬𝗪. This is a humanoid robot developed by Hanson Robotics that can mimic human facial expressions, converse with humans, and even obtain citizenship in Saudi Arabia. However, robotics and artificial intelligence also face many challenges and limitations that need to be addressed in order to realize their full potential. Some of the major challenges are ethics. This is how we ensure that robots and AI systems are aligned with human values and morals, and do not cause harm or injustice to humans or other beings. For example, how do we ensure that robots and AI systems respect human dignity, privacy, autonomy, and diversity? Safety. This is how we ensure that robots and AI systems are reliable and robust, and do not malfunction or behave unpredictably in uncertain or adversarial situations. For example, how do we ensure that robots and AI systems can cope with errors, failures, attacks, or changes in their environment? Societal. This is how we ensure that robots and AI systems are beneficial and fair for society, and do not create or exacerbate social problems or inequalities. For example, how do we ensure that robots and AI systems do not replace or displace human workers, create biases or discrimination, or undermine human dignity or agency? What are some of the potential applications and implications of robotics and artificial intelligence for the future? Robotics and artificial intelligence have the potential to transform various domains and industries in the future, such as healthcare, education, agriculture, manufacturing, transportation, entertainment, etc. Some of the possible applications and implications of these technologies are healthcare. Robots and AI systems can assist doctors and nurses in diagnosis, treatment, surgery, rehabilitation, etc. They can also provide personalized care and support for patients and elderly people at home or in hospitals. Education. Robots and AI systems can enhance learning outcomes and experiences for students and teachers. They can provide adaptive curriculum, feedback, and tutoring, as well as facilitate social and emotional skills development. Agriculture. Robots and AI systems can improve crop yield and quality, reduce labor costs, and minimize environmental impact. They can perform tasks such as planting, harvesting, weeding, and spraying. Manufacturing. Robots and AI systems can increase productivity, efficiency, and quality, reduce waste, and optimize supply chains. They can perform tasks such as assembling, welding, painting, and inspecting. Transportation. Robots and AI systems can improve safety, convenience, and sustainability. They can enable autonomous vehicles, smart traffic management, and intelligent logistics. Entertainment, robots and AI systems can create new forms of art, music, games, and storytelling. They can also provide immersive experiences, personalized recommendations, and social interactions. Job loss, robots and AI systems may replace human workers in many sectors and occupations, leading to unemployment, income inequality, and social unrest. Privacy loss, robots and AI systems may collect, store, analyze, and share personal data without consent or oversight, leading to surveillance, manipulation, identity theft, and cyber attacks. Human loss, robots and AI systems may surpass human intelligence and capabilities in all domains, leading to loss of control, autonomy, dignity, and meaning. Conclusion: robotics and artificial intelligence are fascinating fields that have made remarkable progress in recent years. Machine learning, algorithms, techniques, and applications. Introduction. Hello and welcome to this video on machine learning, algorithms, techniques, and applications. In this video, we will explore what machine learning is, how it works, and what are some of the real-world applications of machine learning. We will also look at some of the popular machine learning algorithms and techniques that are used to solve various problems and tasks. Machine learning is a branch of artificial intelligence that enables computers to learn from data and experience without being explicitly programmed. Machine learning algorithms can analyze large amounts of data, find patterns and trends, and make predictions or decisions based on the learned knowledge. Machine learning can be used for various purposes, such as classification, regression, clustering, recommendation, anomaly detection, natural language processing, computer vision, speech recognition, and many more. Machine learning algorithms can be broadly classified into 4 categories: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Supervised learning is when the algorithm learns from labeled data, that is, data that has a known output or target variable. For example, a supervised learning algorithm can learn to classify images of cats and dogs based on labeled examples. Unsupervised learning is when the algorithm learns from unlabeled data, that is, data that has no known output or target variable. For example, an unsupervised learning algorithm can learn to cluster customers based on their purchase behavior without knowing their preferences or segments. Semi-supervised learning is when the algorithm learns from a combination of labeled and unlabeled data. For example, a semi-supervised learning algorithm can learn to identify spam emails based on a few labeled examples and a large amount of unlabeled emails. Reinforcement learning is when the algorithm learns from its own actions and feedback from the environment. For example, a reinforcement learning algorithm can learn to play a video game by trial and error and by receiving rewards or penalties for its actions. Machine learning techniques are the methods or processes that are used to implement machine learning algorithms. Some of the common machine learning techniques are linear regression, logistic regression, decision trees, support vector machines, k-means clustering, principal component analysis, neural networks, deep learning, etc. Each technique has its own advantages and disadvantages depending on the type and complexity of the problem and the data. Machine learning applications are the real-world scenarios or domains where machine learning algorithms and techniques are used to solve problems or perform tasks. Machine learning applications are everywhere in our daily lives, such as social media features, product recommendations, image recognition, sentiment analysis, automating employee access control, marine wildlife preservation, regulating healthcare efficiency and medical services, predicting potential heart failure, stock trading, cybersecurity systems, smart cities, e-commerce, agriculture, and many more. In this video, we will discuss some of these applications in more detail and see how machine learning algorithms and techniques are applied in them. Social media features. Social media platforms use machine learning algorithms and approaches to create some attractive and excellent features for their users. Some of these features are face detection and recognition. This feature allows users to tag themselves and their friends in photos automatically by detecting and recognizing their faces. This feature uses machine learning techniques such as convolutional neural networks, CNNs, and face embeddings to learn the features of faces from millions of images and compare them with new images. Content moderation. This feature allows users to report or flag inappropriate or harmful content such as hate speech, violence, nudity, etc., on social media platforms. This feature uses machine learning techniques such as natural language processing, NLP, and computer vision to analyze the text and images of the content and classify them into different categories based on their suitability. Newsfeed personalization. This feature allows users to see the most relevant and interesting posts from their friends and pages they follow on their newsfeed. This feature uses machine learning techniques such as collaborative filtering and deep neural networks to learn the preferences and interests of users based on their past interactions and behavior on the platform. Trending topics. This feature allows users to see the most popular topics or hashtags that are being discussed on social media platforms at any given time. This feature uses machine learning techniques such as natural language processing, NLP, and sentiment analysis to extract keywords and phrases from millions of posts and tweets and measure their frequency and polarity. Product recommendations. Product recommendations are one of the most common applications of machine learning in e-commerce platforms. Product recommendations aim to suggest products or services that users might like or need based on their previous purchases, browsing history, ratings, reviews, etc. Product recommendations use machine learning techniques such as collaborative filtering and matrix factorization to learn the preferences and tastes of users and products from large amounts of data and generate personalized recommendations for each user. Product recommendations can help increase customer satisfaction, loyalty, retention, and revenue for e-commerce platforms. Image recognition. Image recognition is the ability of machines to identify and classify objects, people, places, scenes, etc., in images. Image recognition is one of the most challenging and exciting applications of machine learning in computer vision. Image recognition uses machine learning techniques such as convolutional neural networks, CNNs, transfer learning, and object detection to learn the features and patterns of images from large datasets and recognize them in new images. Image recognition can be used for various purposes, such as face recognition, biometric authentication, medical diagnosis, self-driving cars, security surveillance, etc. Sentiment analysis. Sentiment analysis is the ability of machines to understand and analyze the emotions, opinions, attitudes, etc., of people expressed in text or speech. Sentiment analysis is one of the most useful applications of machine learning in natural language processing, NLP. Sentiment analysis uses machine learning techniques such as natural language processing, NLP, text mining, and deep neural networks to process and extract the sentiment or polarity of text or speech from different sources such as social media posts, reviews, comments, feedbacks, etc. Sentiment analysis can be used for various purposes, such as customer service, market research, product analysis, social media monitoring, etc. Automating employee access control. Automating employee access control is an application of machine learning that aims to improve the security and efficiency of workplaces by using biometric authentication systems. Biometric authentication systems use machine learning techniques such as face recognition, fingerprint recognition, iris recognition, etc., to verify the identity of employees based on their unique physical or behavioral characteristics. Biometric authentication systems can help reduce the risk of unauthorized access, fraud, theft, and human errors in workplaces. Marine wildlife preservation. Marine wildlife preservation is an application of machine learning that aims to protect and conserve the marine ecosystems and biodiversity by using smart sensors and drones. Smart sensors and drones use machine learning techniques such as image recognition, object detection, and deep neural networks to monitor and track the movements and behaviors of marine animals such as whales, dolphins, sharks, turtles, etc., and detect any threats or dangers such as illegal fishing, poaching, pollution, etc. Smart sensors and drones can help collect valuable data and information about the marine wildlife and environment and alert the authorities or conservationists in case of any emergency or intervention. Regulating healthcare efficiency and medical services. Regulating healthcare efficiency and medical services is an application of machine learning that aims to improve the quality and accessibility of healthcare services by using data analytics and artificial intelligence. Data analytics and artificial intelligence use machine learning techniques such as natural language processing, NLP, computer vision, and deep neural networks to analyze and process large amounts of medical data such as electronic health records, medical images, genomic data, etc., and provide insights and solutions for various healthcare problems and tasks such as diagnosis, prognosis, treatment, prevention, etc. Data analytics and artificial intelligence can help enhance the accuracy and efficiency of healthcare services and reduce the costs and errors. Predicting potential heart failure. Predicting potential heart failure is an application of machine learning that aims to prevent and treat heart diseases by using predictive analytics and machine learning models. Predictive analytics and machine learning models use machine learning techniques such as logistic regression, decision trees, to learn from historical and current data of patients such as age, gender, blood pressure, cholesterol level, etc., and predict their risk or likelihood of developing heart failure in the future. Predictive analytics and machine learning models can help identify and alert high-risk patients and provide them with timely and personalized interventions and treatments. Stock trading. Stock trading is an application of machine learning that aims to optimize and automate the trading strategies and decisions by using financial analytics and artificial intelligence. Financial analytics and artificial intelligence use machine learning techniques such as linear regression, time series analysis, reinforcement learning, etc., to learn from historical and real-time data of stocks such as price, volume, trend, sentiment, etc., and predict their future movements or fluctuations. Financial analytics and artificial intelligence can help traders and investors to make better and faster trading decisions and maximize their profits. In this video, we have discussed what machine learning is, how it works, and what are some of the real-world applications of machine learning. We have also looked at some of the popular machine learning algorithms and techniques that are used to solve various problems and tasks. Machine learning is a powerful and fascinating field that has a lot of potential and opportunities for innovation and improvement. Let's know about AI in education, personalized learning and intelligent tutoring systems. In this video on AI in education, personalized learning and intelligent tutoring systems. Now, we will explore how artificial intelligence, AI, is transforming the education landscape by providing personalized and interactive learning experiences for students. What is AI in education? AI in education is the use of AI techniques and technologies to enhance learning and teaching processes, outcomes, and environments. AI can help educators design more effective and engaging curricula, assessments, and feedback mechanisms. AI can also help learners access more customized and adaptive learning resources, tools, and support. One of the main goals of AI in education is to create personalized learning experiences that cater to the individual needs, preferences, goals, and abilities of each learner. Personalized learning can improve learner motivation, engagement, retention, and achievement by providing relevant, meaningful, and timely learning opportunities. What are intelligent tutoring systems? Intelligent tutoring systems, ITS, are AI-powered tools that provide personalized guidance and feedback to students, mimicking the role of a human tutor. These systems employ machine learning and natural language processing techniques to understand student inputs, evaluate their understanding, and provide targeted assistance. ITS can adapt to the pace, level, style, and interests of each student, offering scaffolding, hints, explanations, examples, and corrections as needed. ITS can also monitor student progress, identify strengths and weaknesses, and recommend optimal learning paths and strategies. Some examples of ITS include Auto Tutor, which teaches students complex topics such as physics, biology, computer literacy, and critical thinking through natural language dialogue. Assessments, which provides students with immediate feedback and hints on math problems while also generating reports for teachers on student performance. What are the benefits of ITS? ITS have several benefits for both learners and educators. Some of these benefits are: improved learning outcomes. ITS can help students achieve higher levels of comprehension, retention, transfer, and application of knowledge and skills. Increased learner autonomy. ITS can empower students to take charge of their own learning by providing them with personalized support and choices. What are the challenges of ITS? Despite the potential benefits of ITS, there are also some challenges and limitations that need to be addressed. Some of these challenges are: technical issues. ITS require sophisticated AI techniques and technologies that may not be readily available or accessible for all learners and educators. Moreover, ITS may encounter errors or bugs that may affect their functionality or reliability. Pedagogical issues. ITS need to be aligned with sound pedagogical principles and practices that ensure the quality and validity of the content, instruction, assessment, and feedback they provide. Moreover, ITS need to be integrated with other learning resources and activities that complement their strengths and weaknesses. Ethical issues. ITS raise ethical concerns regarding the privacy, security, ownership, and use of the data they collect and generate. Moreover, ITS may pose risks of bias or discrimination that may affect the fairness and equity of the learning outcomes they produce. Conclusion. AI in education is a promising field that aims to create personalized learning experiences for students by using intelligent tutoring systems. These systems can provide adaptive guidance and feedback that can improve learner outcomes, autonomy, motivation, and efficiency. However, these systems also face technical, pedagogical, and ethical challenges that need to be addressed carefully and responsibly. Now we learn about AI and creativity, from art and music to writing and design. This video on AI and creativity. From art and music to writing and design. In this video, we will explore how artificial intelligence, AI, is changing the way we create and consume creative works, such as art, music, design, or written content. What is AI and creativity? AI and creativity is the use of AI techniques and technologies to generate, enhance, or evaluate creative works. AI can help us create original compositions that mimic human creativity, or augment our own creative abilities with suggestions, feedback, or inspiration. AI can also help us consume creative works by providing personalized recommendations, analysis, or interpretation. AI can also help us appreciate the diversity and complexity of creative works by exposing us to new styles, genres, or perspectives. How does AI create creative works? AI creates creative works by using algorithms and machine learning to analyze data and create new compositions that follow certain patterns, rules, or preferences. AI systems can learn from large data sets of existing creative works, such as paintings, songs, designs, or texts, and generate new works that are similar or different from them. Some examples of AI systems that create creative works are DALL-E, which can generate realistic images based on any text prompt; Jukebox, which can generate music in various genres and styles; GPT-3, which can generate fluent text on any topic or style; ArtBreeder, which can generate portraits, landscapes, or abstract art by blending different images. What are the benefits of AI for creativity? AI has several benefits for creativity, both for creators and consumers. Some of these benefits are: increased productivity. AI can help creators produce more creative works in less time by automating some aspects of the creative process, such as generating ideas, editing, or formatting. Improved quality. AI can help creators improve the quality of their creative works by providing feedback, suggestions, or corrections. Expanded diversity. AI can help creators explore new possibilities and variations of their creative works by generating different options, styles, or perspectives. Enhanced personalization. AI can help consumers find and enjoy creative works that match their preferences, interests, or moods by providing recommendations, analysis, or interpretation. Enriched appreciation. AI can help consumers appreciate the diversity and complexity of creative works by exposing them to new genres, styles, or perspectives. What are the challenges of AI for creativity? Despite the potential benefits of AI for creativity, there are also some challenges and limitations that need to be addressed. Some of these challenges are: technical issues. AI systems require sophisticated AI techniques and technologies that may not be readily available or accessible for all creators and consumers. Moreover, AI systems may encounter errors or bugs that may affect their functionality or reliability. Ethical issues. AI systems raise ethical concerns regarding the privacy, security, ownership, and use of the data they collect and generate. Moreover, AI systems may pose risks of bias or plagiarism that may affect the originality and authenticity of the creative works they produce. Aesthetic issues. AI systems may not be able to capture the nuances and emotions that human creators and consumers experience in the creative process and appreciation. Moreover, AI systems may not be able to account for the cultural and historical contexts and meanings of the creative works they create or consume. Conclusion. AI and creativity is a fascinating field that explores how AI can create and consume creative works, such as art, music, design, or written content. These systems can provide benefits such as increased productivity, improved quality, expanded diversity, enhanced personalization, and enriched appreciation. However, these systems also face challenges such as technical issues, ethical issues, and aesthetic issues that need to be addressed carefully and responsibly. Thank you for watching this video. If you enjoyed this video, please like, share, and subscribe to our channel. See you next time.